Sam Newton is an experienced IT professional with a strong background in infrastructure and providing governance over an organization's technology strategy. Most recently, before coming to Tintri, he managed IT for a manufacturing company for almost 10 years, 8 of which of the company's virtualization environment was powered by Tintri VMstore. And without further ado, here's Sam Newton.
Thank you. I think I'm already mic'd up.
Perfect.
Correct? I'm good with this mic? All right. Again, thank you for joining. I do have one order of business that I need to take care of before we get started. I have a 4-year-old little boy who wanted me to take pictures with his dinosaur on everything I did. So can I do that real quick before we get started? So I'm going to put him right there, and I need a bunch of smiling faces, if that's okay. All right. And there we go. Okay, I'll be able to send that off. Thank you. All right. So, today, I'm here to talk to you about what makes Tintri Tintri. Raise your hands if you've heard of Tintri before. Okay, all right. So, small percentage. Hopefully, I'll introduce you a little bit to it. We make high-performance storage for virtualized workloads. And just to get started, give you a little bit of information of where we're at. I got to get my mouse over here. Tintri is a wholly owned subsidiary of DDN, Data Direct Networks. Data Direct Networks is the largest privately held storage provider in the world. Their primary focus for the last 20-some years has been high-performance computing. So those organizations that are mapping the human genome or doing DNA sequencing, or my colleagues even joke, helping Elon get to Mars, right? Massive data sets that they even integrate with NVIDIA GPUs to process with. So that's their focus. They purchased Tintri, particularly the VMstore, to gain market share in the enterprise realm. So we would refer to DDN as at scale and Tintri as the enterprise portion. Go to the next slide here. So what makes Tintri Tintri? We do storage very differently than your traditional storage provider does. So what we're going to be discussing today is our current model line, which is the T7000 series. This is a 2U device with redundant controllers, redundant power supplies, and up to 24 NVMe drives. So we've leapfrogged hybrid arrays, we've leapfrogged all-flash arrays, and going with the highest performance NVMe, which takes advantage of the NVMe solid-state performance, but also takes advantage of the NVMe bus interface, which I was surprised to learn is significantly more capable than your standard SCSI interface, typically attached even to flash drives. So the NVMe interface can handle 64,000 channels, each with 64,000 disk commands per channel, compared to your traditional SCSI interface, which might be 32 channels with 1 disk command per channel. And don't quote me on that, but you can see the massive difference with going with a full NVMe infrastructure. The VMstore is designed to integrate with a hypervisor. So VMware, vCenter in particular, but also Hyper-V, Citrix Xen Server, and the Red Hat flavor, I believe, is KVM. And the reason why we do this is because we need the tight integration with the hypervisor to gain information about the individual virtual machines that we're going to be serving. And I'll explain why here in a moment. So another way that we're very different than your traditional storage is we do not have to create disk groups. We do not have to mess with RAID configurations. We do not have to have policies, tiers, nor do we have to have LUNs or volumes for our storage to work. We simply present over NFS or SMB3, NFS for VMware, vCenter, SMB3 for Hyper-V, or our SQL integrated storage product, which I'll explain a little bit later. So we just need a few IP addresses, and then we present that to the hypervisor, and the entire usable storage space of that array is then presented as a single data store. You don't have to carve it up. You don't have to worry about the RAID configurations with it. You don't have to have storage experts to manage that layer of complexity that's typical of traditional storage. So right there, you have a significant benefit because the management overhead is so low. And I can speak to that because I've, like, what was your name again? I'm sorry? Parker. Like Parker introduced me, before coming to Tintri, I was a customer. And I've been in past, I've been in the insurance industry, and after that, I was a network engineer at a casino. And after that, I managed IT for a manufacturing company for almost a decade. When I was looking to refresh storage, I needed something performant but easy to manage because I had a small staff. And with a small staff, you don't have time to manage the additional complexities of LUNs and volumes and the fabric involved, things like that. So I was actually introduced to Tintri by a gentleman named George Crump, at the time ran a blog called Storage Switzerland. I reached out to him and said, hey, I need some guidance on storage array. And there's all these options out there for hybrids and all flash arrays. And he says, well, have you ever heard of a company called Tintri? I said, no. He said, well, you should check them out because you're 100% VMware. And I did, and here I am now, 8 years later. I really, really believe in this product. Okay, so another thing here is we can loosely pool up to 64 of our individual VM stores under our management platform, which we call the Tintri Global Center. So you can see how well we can scale. All right. Another very different characteristic of what makes Tintri Tintri. With your traditional storage, it's typically served to your infrastructure in a LUN or a volume. And forgive my mouse writing, I'm trying to get better at it. So regardless of what the underlying disk structure is here, with the LUN or volume, you're operating in aggregate, and you're optimizing in aggregate. So each individual workload that you have here, you don't have a lot of visibility into what's going on with each of these workloads. You don't have an idea of what their performance characteristics are. You don't have the ability to optimize for each workload. Each one of the IOs has to be processed sequentially. And at best, maybe you can get IOPS, throughput, and latency numbers for the volume or the LUN, but it's still in aggregate. So what does the VMstore do differently than this? Every workload that you move onto the VMstore is immediately given its own dedicated, what you can refer to as a swim lane. So these are discrete and isolated lanes for each workload, and we do this with the tight integration of the hypervisor. Because they're discrete and they're not impacted by other virtual machines. You don't have the noisy neighbor problem. You don't have bully VMs that soak up resources from other VMs. And this is where the artificial intelligence comes in with our arrays. Each one of these swim lanes, if you will, is automatically tuned and optimized with one of the goals of the algorithm is to provide 1 millisecond or less latency per VM. And this is done through auto QoS and managing queue depths. You can set manual QoS on a workload if you want, but we suggest you let the array do what it does best. Any questions so far? No? Okay. I'll just give you a brief description or a brief overview of the Tintri Global Center. And I think we'll have time for me to show you this live. But you can see that our atomic level of management is the virtual machine or the SQL database level. And you can see in that we get that through the tight integration with the hypervisor. So each one of these entries here is a virtual machine. So from your array, you're able to get all of this information and more per workload. And you can start to gather a lot of intelligence, a lot of information, a lot of troubleshooting that you don't have visibility into before. See, did that pop that up? There we go. Now, when you highlight over the latency component per virtual machine, we then break it up because we can, of the tight integration with the hypervisor, you're going to hear me say that over and over again. We then break it up into host, network, storage, and if we're implementing manual QoS, throttle. So I'll show you how we can use this for troubleshooting, but we can give you this level of granularity all the way down to the virtual machine, as I pointed out, as well as individual VMDKs. So this is a lot of information that you can get from the Tintri storage array that you don't get from many other providers. Also, we have a cloud-based analytics platform for customers with current support contracts. We'll maintain up to 3 years of historical data and provide for you up to 18 months of trends, performance trends, space trends. And we've ingested so much data into this platform that we've been able to template a lot of different scenario workloads. So for this one, for instance, gives you historical information. This particular customer had a pretty level performance trend for quite a bit of time. And then all of a sudden, COVID hit. And you can see their performance trends go way up. They had to implement VDI at that point. But that's just an example of getting performance information out of this. We also would have different views that would show you your space consumption trend line, and then think of this as your danger zone when you hit 90%. So based on your information, your space savings factor, your deduplication and compression rates, you can see very accurately when your environment may run out of space or when your environment may run out of performance. So you can back this up into your budgeting cycle and say, hey, I estimate I'm going to run out of space by mid-May 2023. My budgeting cycle starts at the end of this year. I need to plan for that. Or let's say marketing comes to you and says, hey, we're going to need 4 servers, each with 2 terabytes of disk space each. All right, so you can add that in as a template, and you can see how that's going to affect your environment. And I might have time to show you a little bit about that as well. One of the other awesome patented features that we have for our arrays is the way that we can configure them. I'm a sales engineer, so I'll interface with the customer or the partner, and they'll give me some of the specifics. What are the goals we're looking for? You know, what is the footprint we're trying to reach? How much space we're looking for day one free. With our arrays, we have a minimum configuration of 10 drives, okay? So that's about there. So we will try to configure for the customer a minimum configuration so they have room to grow in the future. But when you need to expand the array, There's no expensive data pack that you have to buy. There's no professional services that you have to get. There's no minimum, there we go. There's no, is my HDMI? All right, let's hope that stays. There's no minimum 50 terabyte amount of disk that you have to buy. You can simply add one drive at a time when necessary to expand your array. So you can add one drive at a time, 4 drives at a time, 8 drives at a time, based on how much storage you're trying to get, up until you fill the array. Now, this is automatically included into the underlying RAID 6 that powers this. So you don't have to do, I don't know if you ever ran into this before, but okay, it's time to add storage into your, your 2U, 4U server in the data center. I don't know about you, but I would genuflect first, and then hope the array holds, and then I'd add the storage, I'd read the settings, I'd double check the settings, I'd genuflect again, and then throw the drives in and hope nothing gets blown away, right? None of that. It automatically handles it for you. And it's an investment saving feature. Over time, our main presenter this morning was talking about Moore's Law. Over time, those extra disks are going to get less and less expensive. So it's definitely a investment protection feature for you as a customer or your customers if you're a partner. Talk about our main use cases. Server virtualization, VDI, and Microsoft SQL databases. So I'm assuming most of you understand managing virtual workloads or have the burden of managing virtual workloads, of optimizing performance, making sure you have overhead, and making sure they're protected. With our array-based snapshots, we can protect each individual virtual machine, and with our SQL integrated storage product, we can protect Microsoft SQL databases in the same fashion that we protect virtual machines. Not only that, we can provide the same level of visibility and the same level of performance per Microsoft database, which allows you to restore a SQL database in seconds, or refresh your dev test environment with a production database in seconds, or refresh your dev test environment with a server data drive in seconds. So again, and with the individual swim lanes I showed you earlier, isolating our workloads, it helps reduce, say, boot storms and things like that your VDI environments normally incur. Any questions so far? Okay. Let's talk about our software suite. Analytics, again, we discussed that. That's the SaaS-based platform that customers with valid support contracts can make use of. Cloud Connector, what that currently does is allow you to take array-based snapshots and upload them to an S3 compatible bucket. So instead of utilizing expensive SAN storage space for long-term snapshot storage, you can offload those to an S3 compatible bucket, say AWS, Wasabi. Or if you want to do it internally, you can do Mini.io if you've ever implemented one of those. Roadmap for this is to, instead of it being an S3 compatible bucket, we're going to continue to develop high performance storage arrays. But we're also going to decouple the Tintri OS from the hardware and put that into the cloud of your choice, and then allow you to use our array-based replication to copy data up to the cloud. The next phase of that would then be to allow you to serve I/O from that in the cloud say as a DR solution. All right, secure VM. This takes advantage of self-encrypting drives and with zero impact to performance or our inline deduplication and compression. I know it's easy for me to say that and hard to show that, but self-encrypting drives, if you think about it, are actually always encrypting. It's just you have to implement a key. Typically, they're encrypting with a 0 key, so you're just implementing a key, if that makes sense. So that's how it does not impact performance. Sync VM. This is, in my mind, the most important feature that we have for customers. What this does is if you have your mission-critical virtual machines protected with our array-based snapshots, that is your best resource for restoring your mission-critical workloads in the fastest time possible. This uses array-based snapshots, which we can go forwards and backwards in time because they're pointers underneath the file system. They're not layers like VMware-based snapshots, where if you restore to a snapshot, you have A, B, and C. If you restore back to A, you've lost B and C. Ours are pointers underneath the file system so that if you restore too far back, you can then come back further without losing that capability. Also, because they're pointers underneath the file system, they can't be mounted by ransomware. They can't be mounted by malicious processes. So to use a buzzword, they are inherently immutable and always have been. It's just the design of the file system. So I'm going to be demonstrating Sync VM here in just a little bit, and I think you'll be able to see the definite values from that. Replicate VM, we have two types of array-based replication. We have asynchronous, and we have synchronous with failover. So asynchronous replication basically is only bandwidth bound. So do you have enough bandwidth between your arrays to push a snapshot over to this destination array before the next snapshot is taken? Asynchronous. So that allows you to replicate from array A to array B, and then from array A to array C, array B to array D. You have lots of options for creating significant redundancy. Synchronous replication is basically a high availability play. You have a primary array and a secondary array. Data is written to the primary array, immediately replicated over to the secondary array. The secondary array says, hey, I'm good to go, let's move forward. So the minimum requirements for that type of setup is 10 gig Ethernet between them with a maximum of 10 milliseconds latency. Because you got to have that return from the secondary array. If it's over 10 milliseconds latency, you're going to see impact in performance. You can manually fail that over, or we also have a witness server that'll fail it over for you. So those are the two different types of replication. VM scale out, if you have multiple VM stores under a single Tintri global center managed in our loosely federated pool, it'll give you suggestions on, hey, you could move this workload or this group of workloads from this array to this other array to balance out performance and storage. It's kind of like storage DRS, like vCenter has for virtual machines. So let's just talk the model lineup and capacities. So the T7000 series is broken up into three different models: the T7040, the T7060, the T7080. Does anyone in here operate an environment that requires FIPS compliance? The federal encryption standard? Kind of, sort of? Yes, okay. So if you did have FIPS compliance or needed to go that route, if you needed more than just the self-encrypting drives at rest, you would need to go with one of these two models, simply because the difference in these three models is the amount of CPU and RAM that's in the redundant controllers. FIPS puts a performance overhead price on your array, so you need more horsepower to accommodate that. That makes sense. All right. These number of VMs are not licensed or hard limits. They're basically guidelines. These are our conservative IOPS estimates per box, and then you can see our throughput. Again, let's talk about now our storage capacity. All three of those models I just showed you earlier can be configured with any of these drive configurations. So right now we have 2 terabyte, 4 terabyte, and 8 terabyte drive configurations. Soon, in the next few months, we'll have 16 terabyte drive configurations. I talked about earlier where the minimum configuration for one of these arrays is 10 drives. So, and we typically speak to our customers in usable capacity. So when I was a customer and I was trying to explain to a colleague what Tintri was, I would tell them it's a giant bucket of performance that you present to your hypervisor. So the usable capacity that we talk in, that is the size of the data store that you present to your hypervisor. There's no carving up, there's no RAID considerations, none of that. It's just simply the usable space that you're providing to your hypervisor. So we can go from, per array, we can go from a minimum of 10.8 usable terabytes all the way up to 129 usable terabytes. We don't typically size for effective higher than 3x. Typical workloads, or typical server-based workloads in my experience have been anywhere from 1.5 to 2.5x. Just depends per environment, your mileage may vary. VDI workloads, of course, you get a significantly higher space savings factors, what we call our deduplication and compression ratio. So you can go a little bit higher with the effective capacity. And again, the last thing I wanted to point out here is if you purchase an array or you have an array for a customer and you start with, say, 2 terabytes, you use the 2 terabyte configuration. Because of the underlying RAID 6, when you go to expand that in the future, you have to continue using that same size drive. Does that make sense? Okay. That's because sometimes I get asked, well, can we mix and match different sizes? Or can we pull out the small drives and put in new drives? No, we can't do that. Finally, this is our connectivity. So it's gigabit. I'm sorry, Ethernet. Not gigabit, it's Ethernet. So we present either NFS or SMB3 from 10 gig all the way up to 100 gig, just depending on the backbone or your top of rack switch capability. All right. Now, roadmap or questions at this point. Some of you got to have some questions. Oh, I'm sorry. Was there supposed to be questions here? I'm sorry. Okay.
There is none.
Okay. All right. All right. Well, I can give you a little bit of the roadmap. We are going to continue to build on-premise physical appliances, but we're also going to be decoupling the Tintri OS from the appliance for you to allow you to put it into the cloud of your choice. And again, that will allow you to use array-based replication and eventually for a DR play. We also have, we will have the ability to integrate with a partner that will constantly be able to take snapshots of your virtual machines and open them up in a sandbox environment and continually pen test them and check for malware processes and check for, bugs and any malicious process we're looking for. All of that would be non-performance impacting because it's array-based snapshots moving that over. Also, with that same technology, we will be able to implement a DR scenario as well, where you could test in a sandbox environment. So, at this point, I'd like to show you a little bit of the, let's see if we're duplicating. All right. I'd like to show you a little bit of the Tintri Global Center management interface. Again, this is typical information that you would expect from a management platform for your storage in your environment. You've got your IOPS, throughput, latency. We have this flash hit ratio, which is becoming more and more irrelevant. It's only for our hybrid arrays. And I skipped over latency because I wanted to show you this. All this information is in aggregate across all of our VM stores being managed by this Tintri Global Center. As you can see, this lab is a little bit smaller, so there's only 64 virtual machines or managed objects here. But if you hover over latency, we're beginning to break it down per host, if it's host-based latency, if it's network-based latency, if it's storage-based latency, or if you have manual QoS you've implemented. For instance, I have a customer right now who's reporting very high intermittent network and host latency. So the part of the graph that's showing the performance is mostly network latency with a little bit of host on top. And we think that's a LACP configuration issue. We're working that out right now. This here is what I would describe as a thermometer for your environment. It's a combination of performance and space reserves. So once it gets to about 40% free, this is a good indication I need to consider adding more storage, adding more performance. This here is pretty standard. It's your live data, it's your snapshots, and your free space. Let's say we're tracing down a latency issue. And if we have a customer or user base who's calling in saying, hey, this particular application is running slow. And all right, the finger pointing exercise is about to begin. Your host server team is going to say, we think it's the network. The network team says, no, we think it's the storage. Well, here, because of the visibility we have, we're going to be able to tell you what direction you need to go to troubleshoot these workloads. So let's say the host here, if that's easy for you to see, instead of 0 milliseconds, says 45 milliseconds of latency. All right, we have a problem. So we can go to our VM stores, and now we have 2 VM stores in this particular lab. Let's say, so we got 53 virtual machines on this one, 12 virtual machines here. Let's say one of these shows 45 milliseconds of latency. So we can hover over this, and again, for the sake of argument, it's listing under the host category. All right, so we can click here, go into the VM store, we can go to Manage Objects, which are the virtual machines living on the VM store, sort it by latency. Just for the sake of argument, let's say this Tingle DP3 is the server involved in your workload. You can highlight over that. Again, yep, we're seeing that same host latency there. So we're going to go to that virtual machines properties, and we're going to identify that we need to send our team, the host server team, to this specific VM host to begin troubleshooting. Maybe the VCPUs are configured wrong. Maybe they've overcommitted memory and it's swapping to disk. Maybe there's a runaway process. Whatever it is, we know with this visibility, that's where you need to begin troubleshooting. All right, switching gears. I'd like to talk about the array-based replication and then maybe we'll get you back to your day a little bit sooner. I'm sorry, the array-based protection with our snapshots. So again, as I had indicated before, your best bet in protecting your mission-critical workstations, your mission-critical server workloads, is to have array-based snapshots in place so you can recover in as fast of a fashion as possible. So with the Tintri VMstore, you can configure your snapshots, your array-based snapshots, basically 3 different ways. One is globally across the entire VMstore. Secondly is with what we call a service group, which could be dictated by vSphere tags or by VM folders in your vCenter, and individually per workload, per virtual machine. So we're going to jump over to vCenter here. And here's my ransomware victim virtual machine. First thing I want to show you is that we have 0 vCenter snapshots on this virtual machine. But Tintri makes a vCenter plugin so that we can let our administrators continue to use the interface that they're most comfortable with, vCenter, instead of having to switch between other interfaces. Especially during the fog of war, we don't want them to have to go to an interface they're not really familiar with. We want them to stay in vCenter. So our vCenter plugin allows us to right-click on a virtual machine, go to All Tintri Actions. Come on, little guy, you got this. Yay. And we can do a number of different actions. This gives us visibility into the array. The first thing I want to show you is we're going to view our array-based snapshots from within vCenter. So now, this is presuming we have already configured this and we know that this array or that this virtual machine is protected by our snapshots. This is just showing you that we do have array-based snapshots in place on this particular virtual machine. You can actually take an array-based snapshot if you'd like. You can clone the virtual machine, and you can restore the virtual machine from this particular interface. So, worst case scenario, this is a server that we have in our environment that supports an application that makes our world go round in our environment, in our business or our customer's business. There's 200 gigs of customer data, 200 gigs of supplier contracts, and other executables and DLLs that make our service work. Unfortunately, we have an administrator or a user that did not pay attention to the security awareness training. I don't know if you have that in your environment. Maybe KnowBe4, maybe something like that. And they got an email that urged them to do something right away, right? So they clicked the link, they downloaded the file, or they executed the infected file that we didn't want them to execute. So then a ransomware process begins in our environment. And that's all the longer it takes for our data to become encrypted. All right? So a ransom note's going to pop up here in a second. This is a simulator, so forget the fact that there is a recovery key here. We know we're not going to have the recovery key when we get attacked by the bad guys. So this is where I'd like to make it a little bit interactive. In your environments, when this happens, what is your approach? What would you have to do to recover this workload? And how much time do you think that would take? Anybody? Yes. Well, if you don't have array-based snapshots, some of the numbers I've heard for if you have, say, disk-based backups, days. It may take days to recover. If you have tape-based backups, we're talking weeks to months, particularly on the scope of the attack or the loss of data. Is anyone familiar with some of the backup and protection capabilities within their environments? No? Okay. All right, that's fine. So yes, depending on a lot of my customers that I talk to, they may take a backup every 24 hours, right? So it's done every night. And when you have to restore that workload, you may have to accept up to 24 hours of data loss. That's a lot. Or you may have to accept even more. Okay. So then they have to find the backup, transfer it across the network, and restore hundreds of gigs or terabytes of data across the network. And yeah, that could take minimum hours. With Tintri array-based snapshots in place, to restore a virtual machine, you'd simply right-click, all Tintri actions, synchronize, and restore VM. But I want to minimize this for a second. Again, all Tintri actions, synchronize, restore VM. Again, we're choosing VM to restore, and we're going to choose I'm going to move one snapshot back, and I'm going to click restore. Done. Immediately, that virtual machine is rebooted. The snapshot that we chose is reassociated with the VMDKs involved, the disks involved. The VMX descriptor file is restored and reread into the system, and then it is rebooted back to that point in time. And it's complaining because it's a crash consistent snapshot. It's like we pulled the power out from under it. But we have just restored an entire virtual machine in a matter of seconds. So maybe we don't replace your entire backup and protection scenario, but we can significantly augment it. Because time is money, right? All right. Also, a lot of times it's not the worst case scenario. It's not ransomware. Let's say it's a Windows update that goes bad. We can simply restore the C drive of that virtual machine without touching anything else and get you back and running. Let's say an administrator accidentally deletes a data drive or accidentally runs a command that wipes the data drive. We can restore that individual data drive in a matter of seconds. Oftentimes, even that's too much of a sledgehammer, because there's other files that have been updated or something and they don't want to affect that on that data drive. So we can mount a snapshot of that data drive as a new data drive and simply copy and paste the files that you need to restore. So there's a lot of capabilities with that. Final thing I wanted to show you. Before the vCenter plugin or the Tintri will take any actions with snapshots on your virtual machines, it will immediately take a safety snapshot so that if one of your administrator restores the wrong virtual machine, we can revert to that safety snapshot and be back up and running where we were before. Pretty cool? So that's pretty much all I wanted to show you today. Thank you for your time. Thank you for your attention. Does anybody have any questions on that, or? No? Okay. And no questions here either, so.
Well, thank you guys all for coming out here again to Envision. We couldn't do this without you guys, especially big thank you to Sam Newton for stopping by and taking time out of your busy day to give us a good presentation. So let's give him a round of applause.
Thank you.